Alright, in this tutorial, we'll be talking about the basic outline of the GVA software that was installed in the previous video. So opening up the software opens that terminal first, but then the primary application subsequently. In the primary application, the configuration is on the left-hand panel here. The first thing that can be done is to select where the experimental directory will be. So if you click this button, it will bring up a folder that can be navigated to wherever your data is housed or will be housed. This created a tutorial folder on the desktop, and now that is the folder in the experimental directory. The imaging parameters can be altered and then saved as a default configuration. Several imaging parameters required for the code to appropriately process the data. These include the number of pipette tips per row, the assay volume in microliters, the channel length. This is the actual length of the agarose cone inside the pipette tip. So here 36 millimeters is from the tip of the agarose cone to the base. The number of images per field of view. If multiple images per field of view are taken, then the mean of those images is used to create the final image, which can help reduce noise for a particular optical configuration. For the optical configuration that was distributed on the website, we found that one image per field of view is sufficient. Pipettes per field of view, this also depends on the optical configuration, but for ours it shows at 3. The rotate image is required because pipette tips can be imaged in different configurations, and the software requires knowing which way the pipette tips are pointing in the field of view. So this is the first parameter that I would check if you're having problems with the segmenter working. This is likely an error here. All these parameters are stored in a default configuration table that was shipped with the software. So here in this imaging parameter defaults is a CSV file that has the different parameters as well as their values. If for your experimental setup you find that you're always going to be using, say, 200 microliters and 40 millimeter length, if you store this as a default configuration, it will now be updated here, 240, and every time you use the software, it will default to these configuration values. The pixel size is calibrated based on your optical setup, as shown in the tutorial on how to set up the optical box online. Basically just involves taking a picture of a ruler at the plane of view where the pipette tips will be, and then estimating the number of pixels required to span. Down here is the experimental configuration, which is going to be unique to each experiment run. It includes what was the dilution factor into the agarose of your sample. This allows it to account for how much it should multiply the CFU values it calculates by to get to the correct sample concentration. Experiment date, what kinds of embedding matrix was used. All of these values are then written into a table of the experimental folder that allows you to keep track of how you performed each experiment. So what this looks like is this xconfig file, which is written into the folder where your experiment was run. And this is just a CSV file with the directory, the number of images per field of view, etc. It's a good way of bookkeeping. So the main processes that can be run from this app are segmenting pre-existing images or acquiring new images. The acquisition requires it to be interfaced with the optical box that was conveyed on the website, but you can process pre-existing images using the segmenter tab here. And we have some example data that I'll be walking us through each one of these tabs, but the basic outline is segmenter acquisition. Importantly, you can use the segmenter tab without having a camera hooked up to the software. So this is what the acquisition tab usually looks like. If it cannot find the camera, so if I close out the camera, when I click on the acquisition tab, when I click on the acquisition tab, I end up with an error message that it cannot find the Arduino or the camera, but the segmenter tab will still work. In the next videos, I'll talk about how to use the acquisition and segmenter tabs to acquire and segment your pipette tips.